Hi, we are from group MCO 2.0 and we are going to present about stroke prediction dataset under healthcare category. Let's start. First of all, my name is Aqilah Binti Zaki and I'm going to summarize our project title, that is stroke prediction dataset. So, according to the World Health Organization, stroke is the world's second leading cause of death, accounts for about 11% of the total deaths in health categories. So this dataset is used to determine whether a patient will probably get a stroke corresponding to specific criteria such as gender, age, different illness, and also smoking status. Therefore, we decided to put healthcare category as our main research because we found that stroke prediction is most suitable data that we can predict more from it, and our group MCO 2.0 also agreed to take this topic as our prediction tasks in this project. In this project, our group aimed to determine the number of stroke likeliness by exploring the factors. These reasons include age, hypertension, heart conditions, level of glucose, body mass index, smoking conditions, and also the history of the stroke. The dataset is discovered is highly related and convenient because detailed information such as gender, age, type of residence, type of job, and also marital status could be found in these factors. So based on these considerations, we tried to work out few more informations regarding this topic. Our team also wished to predict stroke patients worldwide. For the descriptions, we have so many data in the datasets, which are 5,110. Due to the number of data we have, redundancy could happen. The accuracy of the result may be affected also. So in order to avoid duplications, we have chosen the appropriate features for the project, which is located in the data descriptions and also in appendix as plots. So in short, we propose to achieve good forecast by first analyze and predict stroke cases solely on the basis of correlation metrics, drawings, calculations, and the SPOLMs, or we call it as scatter plot metrics for the data analytics. Once we have discovered the model that best works for our data, we can play with the model parameters and see if we can improve our score even further. And the second is we also include knowledge base in the prediction outcome to create the solutions. Next, I will pass to the next presenter to talk about our problem descriptions.
Hello everyone, today I'll be explaining about the problem description of our project. In terms of business goal, our project is about predicting the cause of stroke, which is based on the stroke prediction dataset, and it contains few factors as attributes to conduct observations and to come up with hypotheses. The purpose of our project is to study the factors of stroke and predict the likeliness of getting stroke. As stroke is the second leading cause of death globally, and stroke is a serious life-threatening medical condition that happens when the blood supply to part of the brain is cut off. Moreover, this project is to get to know if stroke affects the patients with hypertension or heart disease or with a smoking history. In terms of technical goal, our goal is to predict, as I said earlier, is to predict the number of likeliness of stroke by analyzing the factors. So I'm speaking about the factors, and these factors are age, presence of hypertension, presence of heart disease, glucose level, body mass index or BMI, smoking status, and stroke history. The dataset found is actually very relatable and convenient, as these factors can be found in with additional information such as age, gender, residence type, work type, and marital status. And we have come up with some problems. One of the problem is likeliness of stroke in between men and women, likeliness of stroke in between patients who are below and above the age of 50, likeliness of stroke for patients with hypertension, stroke history with high BMI and high glucose level, and likeliness of patients with heart disease.
Hello everyone, I'm Devanesh Arunagiri. Today I'll be talking about data description. Our data set is about stroke prediction which are scraped from World Health Organization. We collected our data from Kaggle.com. Kaggle has a database of CSV files. In this dataset, we get attributes that focus on stroke prediction based on the information gathered. This dataset is used to predict whether a patient is likely to get stroke based on the attributes given. There are 12 attributes in this data: likely, gender, ID, age, hypertension, heart disease, ever married, work type, residence type, average glucose level, smoking status, BMI, and stroke. As you can see, these are the attributes. There are descriptions for each attribute.
Good afternoon, my name is Yuya Fujikawa, and this presentation is going to consist of two parts: data preparation and data interpretation and analysis. Now, to begin with, I'm going to talk about why data preparation is even necessary in the first place to begin with. So when you have big data, usually it's very messy. It contains obsolete rows or duplicated rows, or some columns might be NAs, or it might be improperly formatted. So yes, usually you need to remove all of them, depending on your criteria and what you want to do, before you can do any kind of interpretation or analysis. So first of all, this is a piece of code that removes duplicate rows, but as you can see, even after running the code, we ended up with the same number of rows, which means there was no duplicates for us. Now this is the code that is supposed to remove rows that has one or more columns with the NAs, but it didn't work for us because for us the NA values were literally n/a as opposed to NA, so we couldn't use NA.omit or complete the cases. Now this one is a piece of code that removes rows that have NA for the BMI column, and as you can see, for example, the second row and the ninth row have been eliminated. Now this is a piece of code that converts BMI, which was in the form of factor, to character, and finally to numeric, because we need numeric values to be used in the correlation matrix and the SPLOM. So by default, when you read the CSV file in R, it is interpreted as factors, so that's why I needed to convert the factors to characters and then to numeric. So that's how we did it. Now, moving on to the data analysis and interpretation. First of all, we tried to implement binary classification model by splitting the data into the training set and the test set, but I consistently got this error message that says I can't use the Keras library, even though I had installed the library and I've set the Python paths and everything seemed fine, but it didn't work. So moving on. This is the correlation matrix, essentially showing all of the correlation coefficients for all of the numeric variables available, including to itself. So when you look at the diagonal, you see a value of 1, which is just kind of mapping to itself. This is essentially it's essentially the same as the correlation matrix, except it provides more visual aids with some additional information. Now, to interpret the correlation matrix, obviously there's a lot of things going on at once here, but I'm going to focus solely on the stroke variable, how it's correlating with all the other variables. We can see that the stroke is positively correlated with all of the other available numeric values, except for BMI, which suggests that BMI is not really a strong contributor to stroke. And the strongest contributor was age. So the more you are, the older you are, the more likely you will get stroke. Yes. So this is the likeliness of stroke in men and women. We see that the difference was pretty insignificant, only just 4.14% in females and 4.42% in males. Now this is the likeliness of stroke between patients who are below 50 years old and above 50 years old, and we can see there is a very significant difference for males. For those who are above 50%, sorry, not 50%, age of 50 years old, the likeliness was like 10% compared to only 0.5% for those who are younger than 50, and we see a very similar result with the females. which is consistent with what we saw with the correlation matrix. Now this is the link between hypertension and the stroke. We see a tenuous link, it's not that strong. We can see that 13.3% of individuals who had hypertension had stroke as well at the same time. This right over here is the link between heart disease and stroke. Once again, we see a tenuous link between them, not a strong correlation. Just 17% of the patients with heart disease also got stroke in our data set. And that's it for my presentation. Thank you so much.
Hi, I'm Puteri Aleeza and I will continue to present about my published solution for data description and data prediction. So we move to data description first. In the bar graph of gender, we get stroke is between 40 years old until 60 years old. And the third graph is for female. The frequency of female age to get stroke is between stroke is between 40 years old until 60 years old. And the third graph is for female. The frequency of female age to get stroke is between 40 to 60 years old. And the fourth graph is does it have bar graph of ever married, which is mostly of stroke people is married. So the next graph is a bar graph of smoking status. We can see at this graph that almost stroke people who get strokes never smoke. And the next graph is the bar graph of resident type, which is we can see that the people who get stroke mostly lives in urban places. Next one is the next graph is the bar graph of work type. We predict that the people who might get this stroke is usually work in the private sector. And the next one is the histogram of BMI. The frequency of BMI, we can see here that the highest one is 1400 between 20 to 40 of the BMI. The next one is the histogram of average glucose level. We can see that the highest one is between 50 to 100 and the frequency is 1000, more than 1500. And the next histogram is of heart disease. We can see that the highest is between 0.0 to 0.1 and is more than 4000. And the next histogram is histogram of hypertension. We can see that the highest is more than 4000 this frequency, and it's between from 0.0 to 0.1. And the next histogram is histogram of stroke. We can see that the highest is more, the frequency is the higher more 4000, and it's between 0.0 to 0.1. And we move to the next solution, which is data prediction. In data prediction, we have two solutions, which is one the correlation matrix, and the second one is scatter plot matrix, as you can see in the slides. That's all from me. We can go to the next person.
From the bar plots that we got from data descriptions and solutions in the stroke prediction dataset, we can conclude that 2,994, around 59% of individuals are females, and 2,115, which is 41%, are males, while one has been categorized as other in gender data, followed by 3,353, 66% of them are married, both males and females. Looking at the residency states, which is 51% of 2,596 of the individuals are urban, while 2,514, which is 49%, are from rural areas. In our dataset, the work type has been categorized into 5, which are children, government job, never work, private sector, and also self-employed. So for the private sector, there is 2,925. 57% of them are working in private sector, while second highest rate is self-employed, 819, 60%. The number of children is 687, is slightly higher than government workers, 657, and only 22 individuals are never working or unemployed among 5,110. The number of never formerly smoked and smokes is 1,892, 885, and 789. So 1,544 of them remain unknown, means that the information is unavailable for these patients, for these stroke patients. And that's all from us. Thank you.